Namaste, welcome to Pythagoras Academy. In this video, we'll see how to find the force exerted by the clamp on the pulley. I'll take this example. There's a 5 kg block connected to a movable pulley, passing over a movable pulley through a fixed pulley, which is clamped here as you see. So this is the clamp. So the pulley is clamped here, and a 2 kg block is connected to the movable pulley. Now the question is to find the force exerted by the clamp on the pulley. The pulley is remaining fixed here because of this clamp. This clamp is keeping the pulley fixed at this particular position. Now how to find the force exerted by the clamp on the pulley? So if you observe, if you draw the free body diagram of this pulley, there are two tensions on it. The string here is pulling, tension is always in the direction of pull. So there is a tension T downwards. So there are two tensions acting on this pulley. Now the pulley has tendency to experience the net force in this direction because T and T would cause a resultant force of root 2T. So ideally, if the pulley is not clamped, it would try to accelerate or move in this direction. To keep it fixed at this position, clamp has to counter it. So force exerted by the clamp should be in this direction, opposite to this root 2T, and magnitude of this force should be equal to root 2T. So the force exerted by the clamp on the pulley is root 2 times the tension in the string. So in this question, we have to find the tension in the string. So the answer is root 2 times the tension, which is the force exerted by the clamp on the pulley. So how do we find tension? So take the free body diagram of the 5 kg block. This is 5 kg block. We have 50 newtons here and normal force N acting, and there is tension in the rightward direction. Let the acceleration of 5 kg block be A. So if you have to find the relation between acceleration of the 5 kg block and 2 kg block because we have a movable pulley here. So because this is connected to a movable pulley, suppose pulley goes up by 1 meter. The string released is 2 meters, it is given to 5 kg. So if the velocity of the pulley or 2 kg block is 1 meter per second upwards, then velocity of the 5 kg will be 2 meter per second towards left. Now if you take in the opposite direction, if the velocity of 5 kg block is 2 meters per second towards right, then the velocity of 2 kg block will be like 1 meter per second towards down. So I can say that if the acceleration of the 2 kg block is A down, then this would be 2A. Or you can apply constraint equations and find the relation between acceleration of 5 kg and 2 kg. So simple logic, if 5 kg block moves towards right by 1 meter, the pulley would come down only by half a meter. So acceleration of 2 kg block is half that of 5 kg block. So if acceleration of 2 kg block is A down, 5 kg block it is 2A. Now, so let me write this as 2A and draw the free body diagram of 2 kg block. So we have its weight 20 Newton acting downwards, and there is tension T dash. Now T dash is the tension which is observed in this string. And observe the free body diagram of this movable pulley. So it has got T and T in the upward direction and T dash in the downward direction. All the pulleys given in this question are ideal pulleys, so that will also be mentioned in the question. So we are taking ideal pulleys, massless and frictionless pulleys. There is no friction, so we don't have to bother about the rotatory effect of the pulley. We don't have to bother about the angular acceleration of the pulley because there is no friction, the pulley is not rotating. The string is simply sliding over the pulley, and it is massless pulley. When you are taking light massless pulleys, though the pulley is accelerating, because mass is negligible, net force on it is 0, because net force is mass into acceleration. If mass is tending to 0, the net force is 0. So I can see that 2T is equal to T dash. So basically T dash is equal to 2T. Now the equation here in the horizontal direction I can write T is equal to 5 into 2a. This is the first equation. For the 2 kg block, the equation is, so this is accelerating down with a, so the equation would be 20 minus t dash, which is 2t. I'm writing 2t, that is equal to 2 times a. This is the second equation. How do we solve this? Multiply the first equation by 2. So now you can get rid of 2t. So I'm left out with, when you add these two equations, I'm left out with 20 in the LHS. That is equal to 5 to 10, 10 into 2, 20, 20a plus 2a, that is 22a. So acceleration a is nothing but 20 by 22, that is 10 by 11 meter per second square. 10 by 11 meters per second square is the acceleration of the 2 kg block. 20 by 11 meter per second square is the acceleration of the 5 kg block. Now from the first equation I can find tension. Tension is nothing but 10a, 10 into a. So tension is simply 10 into 10 by 11 newtons. So tension is 100 by 11 newtons. This is the tension. Now coming to the final answer to the question asked, find the force exerted by the clamp on the pulley. Now as we have already discussed here, the force exerted by the clamp is equal to root 2 times t. So the answer F is equal to root 2t, that is equal to root 2 times 100 by 11. So I can write F is equal to root 2 times or 100 root 2 by 11 newtons. This is the answer to the question, and the direction is at an angle 45 degrees with the horizontal, because the tension, two tensions are along horizontal and vertical. 2t would be in this direction, so this angle is 45. Because two equal vectors, the resultant would be along the bisector. So the force applied by the clamp on the pulley is 100 root 2 by 11 newtons. So this is how you deal with these type of problems. Thank you so much.